everyone, my name is Ranger Nicole and I'm so excited to be sharing a little bit of Yellowstone with all of you today. Now, to help introduce our theme, I have this globe with me. And what I would love for you to do as I spin this globe, I would like you to wonder about what you are seeing. What are the first three things that pop into your mind? As I'm looking at this globe, I'm thinking all about how we are all connected and the community of everyone watching at home from around the world. Also, everything that we love and everything that we need for survival is on this planet here. From a just visual standpoint, we can see all of these areas of color, and all these different colors are representing land, and this big blue space is going to be representing water. Now, land and water are the two major factors that are going to be forming and changing the landscape all around us. And if I was to throw this globe 100 times, what is the probability that I would land on a blue space with my thumb? It would be pretty high, and that is because our planet is covered by 71% water. Now today we are going to be discussing how that water that flows through our planet, the water that flows through our bodies, how it is all connected, and how water has made Yellowstone such a unique and special place. Now, in order to do that, we are going to be using one of my favorite things that I get from a national park. That's going to be the park brochure. And when you first open up the park brochure, you can learn all about a park's natural and cultural history, but my favorite part is looking over that map and getting excited about all of the places that I can explore. And that map is going to help us along today. And I have a really big version of that map here. And on this map, we are going to be going on an epic journey. And that journey is going to be following as water droplets through a very special river. And that river is our namesake and actually the longest undammed river in the lower 48 states. Now, this journey we are going to go on, it's pretty long. We are going to be traveling about 671 miles, or in kilometers, 1,079. And to start this journey, you can see this little start section I have here. We actually have to begin out of the park in this southeastern portion here. And when we exit the park in that location, you would be able to get to Younts Peak. And Younts Peak was named after Harry Younts, who was considered the first ranger in Yellowstone. This peak sits at 12,156 feet in the Absaroka mountain range in the Teton Wilderness. And our journey through the Yellowstone River is going to start right above this mountain peak here. And we are going to start up in the sky as a cloud. So condensation is forming these clouds here. And precipitation is occurring as rain, snow, hail, or sleet, and it's falling down, sometimes collecting, as we saw in the Younts Peak photo, in a snowfield. And over time, that water is going to flow downhill to form the headwaters of the Yellowstone River. Now, headwaters is kind of a funky term. In order to understand it a little better, you can imagine your body like a river. So your head is going to be the start of that river, and it's going to flow downhill, down to your feet and collect in different areas or potentially connect to another river body. So the head is going to be the start of our river, and Younts Peak is where the Yellowstone River gets its beginnings. Now, back to our map, and you can actually follow along with this at home. We have a downloadable copy of this map on our website. So we are going to begin down here in the Yellowstone River, and we are going to follow this river in the southeastern portion, meandering through valleys, as that water is bringing really important cold, nutrient-rich waters to the ecosystems, like our riparian ecosystems or river-based ecosystems. And it's also bringing in lots of important sediment as well. Now that river is then going to travel all the way to a bigger body of water. And I'm going to give you a few hints in order to guess what that lake is called. Now this lake, like I said, is really, really big. It is just over 130 square miles. And if you were to place the cities of Detroit, Michigan, or Las Vegas, Nevada, or Mobile, Alabama, it would just fit within this square mile area. It is the largest North American lake above 7,000 feet. And it was formed and sculpted by volcanism and glaciation over thousands of years. Now, do you have any good guesses? If you said Yellowstone Lake, then you are correct. So this is a picture of Yellowstone Lake that is found on our map. In the bottom, you can see in the yellow highlighter, Yellowstone River entering the lake. And that's not the only body of water that enters this lake here. It's fed by 141 smaller tributaries or streams into that larger body of water. This site is also one of the most extensive conservation efforts in the National Park Service, and that is in hopes of protecting and preserving our native trout species. And this is a photo here of some of our amazing scientists that are studying our fish species. And this massive body of water also piques the interest of scientists from all over the world. And they are checking out the hydrothermal activity that is happening deep under the cold waters. Now, Yellowstone Lake only has one outlet, and that outlet can be found by Fishing Bridge. So again, as we're traveling through the Yellowstone River, as those water droplets, we are going to travel through this lake. We may stay in there for a day, an hour. We may even stay in there for, maybe 1,000 years if we're feeling like it. So that Fishing Bridge outlet is going to be found right there. And that water is exiting at a really impressive rate. And that is about 2,000 to 9,000 cubic feet per second. Now, if you can imagine a basketball, that is about the size of 1 cubic foot. So the amount of water that is leaving this section here is about 9,000 basketballs that's rushing out. And the Yellowstone River, again, is the only outlet that is able to transfer that water. So as we are moving along, we are going to be flowing through Hayden Valley until we get to a really iconic location of two of the most famous formations in the park. Another hint, one is right behind me. And that is going to be where the Yellowstone River is flowing into the Grand Canyon of the Yellowstone. It's cascading down lower and upper falls. So we're going to take just one moment to appreciate the beauty of this area. And as we're appreciating all that we are seeing right now, so this multicolored canyon and the water rushing over to flow further in, I would like you to imagine exactly how this canyon formed. A canyon that is roughly 20 miles long and that could fit about 10 Eiffel Towers side by side at its widest and deepest parts. How do you think it formed? The story is pretty iconic to what makes Yellowstone so unique. And that is going to take us back 640,000 years ago to when our caldera formed. In this area here, there was a lot of lava, ash, and tuff that filled in all that I can currently see. And when that happened, so this area was all covered in, over time, hydrothermal features, so that hot water features, actually weakened all of that newly hardened rock. Then, as water was flowing down over these cascades, it was carving in to that weakened rock and slowly carving out this canyon over thousands and thousands of years. Now I have a picture of that expansive canyon here. Now, this canyon and these waterfalls and other waterways in Yellowstone National Park have inspired people for generations. And someone who's particularly influential to Yellowstone National Park, who was a pretty impressive painter, if I do say so myself, was Thomas Moran, an artist whose paintings helped to highlight the park's need for protection in 1871. He beautifully captured the colors of this canyon. This painting is called The Grand Canyon of the Yellowstone, and you can see it in the Smithsonian Museum of Art. Now, how have you been inspired by the waterways of Yellowstone? Have you painted like Thomas Moran? Or maybe you have written many poems or journal entries, or I personally like to sketch when I'm out here in nature. It gives you a really great opportunity just to pause and imagine the journey that has taken to make these landscapes the way that they are today. Now, I know that waterfall is a little further back, so I have an up close and personal view for you all to see. And again, you can see those beautiful colors here. And those colors are another great example of how water makes Yellowstone such a unique place. So I mentioned hydrothermal features helped to weaken the rocks, but they also help to transform the rocks by changing their color as that hot water interacted with rhyolite and other sediments. Now, the water is cascading pretty quickly. It's very impressive, and you might even be able to hear it from this video right now. And that water is actually cascading down 63,500 to 5,000 gallons per second. Now, the average bathtub can fill to about 80 gallons. So that would mean that about 62.5 to 794 bathtubs of water are falling down that waterfall any second, which is a pretty impressive feat, if I do say so myself. Now, we are going to continue our water journey, and we're going to flow through this canyon, down those waterfalls, and we are going to keep on going out of the caldera rim until we get to about the Tower Falls area. And this is a really important area for the Yellowstone River because it's where the confluence is with the Yellowstone and the Lamar River. From there, the river continues to flow northwest here until it actually exits the park out of Gardner, Montana. But it doesn't stop there. It continues to flow in this northern direction until it hits the Missouri River, and then eventually it will actually flow into the Mississippi River, and we'll find out in just a moment where it will end up from there. Whew! You may be exhausted. I know I've been talking a lot, but we actually just traveled 671 miles along our namesake again, the Yellowstone River. Now, another view of that journey can be from an aerial perspective. And this picture represents all of the water that is actually draining into the Yellowstone watershed or water basin. Now, a watershed is an area where water flows downhill unless it's evaporated, freezes, or absorbed as groundwater and collects in a particular outlet like a river. Now, in our case, that particular outlet is that Yellowstone River. Now, this basin here is really large. It's about 70,000 square miles, about the size of Oklahoma, which is really, really large. Now, that water, like I said, doesn't stop there. It continues into the Yellowstone watershed, to the Missouri watershed, out to the Mississippi, and down to the Gulf of Mexico. Another way to think of a watershed is by looking at this model here. Now, a watershed, again, is an area where water drains downhill. So it is going to be defined by the topography or those ridges. Now, I'm going to add a little water to this model, and we should be able to see that water flowing downhill and collecting in different areas. And the flow speed and rate will definitely be determined by how much water is flowing. But you can see that it is collecting in this lower bit and then flowing down and can even keep flowing out to connect to another river. Now this is just one watershed here, but watersheds can be connected. So on the other side of this mountain range, if I was to do the same thing and add a little water, as rain, snow, sleet, or hail, it's going to fall on the other side. So we have one watershed here where the water is flowing down and collecting, and another watershed here where the water is flowing down and collecting on that side. Now Yellowstone is similar. We do not just have one watershed that is home to the Yellowstone River. We actually have 4 major watersheds. And we have 3 that you can see in these bolder colors here. And the other one is there as well. And these watersheds house 10,000 hydrothermal features, over 25,000 miles of running water, 600 lakes and ponds. The water portion of Yellowstone makes up 5% of its 2.2 million acre area. And as we zoom out of the country, you would actually see many of these watersheds that are connected. And we can keep on zooming out until we see the entire continent of North America. Now, there are a couple different Great Divide, or one Great Divide, a couple different continental divides. And these are watersheds that allow for water to travel from one side of the country to the other. So for example, if water is traveling on this side, or my right side of this red line here, the Great Divide, it will eventually lead to the Atlantic Ocean. And if it's going to flow on the other side of that ridge line, it will flow into the Pacific Ocean. And I have another model just to show you that continental divide. And this is a very simplistic model. So there are lots of mountain ranges that cover North America. And this model here has the United States. It has Mexico down below where the continental Great Divide continues to the south. And we have Canada and Alaska up here to the north where the continental divide continues there as well. Now, so again, if water is flowing on this side of that Great Divide, it would get to the Pacific. This side, it would get to the Atlantic. Now, Yellowstone National Park sits in a really unique spot along this continental divide. And we can see that by looking at our handy dandy map again. And I'm going to trace that continental divide in red. So water that is flowing north of that divide is going to get out eventually, like I said, through the Missouri, from the Mississippi to the Gulf of Mexico, and the water on this side is going to eventually get out to the Pacific Ocean. Now the journey of that water does not stop there. It has the opportunity to travel all over the planet. It has the opportunity to travel to your ecosystems, your homes, and directly impact all of our lives, as well as make Yellowstone what it is today.